Hello, everyone, and a good day to you all. We are here to talk about the SAS optimization challenge that we were given by Professor Lanham and the SAS team. And we are very honored that you've got a chance to work on this. So this is what we have been able to come up with in the time constraint that we have faced. So let's begin. So the agenda of our presentation here is that I'll just introduce you to the team who've worked on this project briefly and talk about the business problem, the process flow that we followed, the exploratory data analysis that we did, the forecasting, optimization, and the results that we achieved. So we are a team of 5 members who work for the MS BAME program. And as you can see on the screen here, these are the members. Moving on, this is the business problem that we were given. So the client, basically, that's the corporation XYZ who wanted an optimal cost for the water distribution in their headquarters. And they were given 2 contracts, basically. And we have to, our objective was to come up with the contract which would save them the most money and distribute the water throughout the building for their purposes. Moving on. So this is the process flow that we followed. We started with the exploratory analysis, then we moved on to the forecasting, then we moved on to the optimization, and finally we ended with the result. For the exploratory analysis, we began with the graph and we saw how the forecast was for over the past 1.5 years. As you can see on the data over here, there is a cyclical pattern, and you can see how like each week the water consumption has varied over time. And if you look at the different purposes that the water has been used for, you can see that for the cooling, the demand was more during the summer seasons, whereas for the main, it has been according to the seasons. So once we were able to do an exploratory analysis, we began with our optimization and forecasting in the project using the SAS software, and our results led to the following values. So as you can see, the values on the screen here are the forecasted amount or the liter of water in gallons. So what we did here is we are showing you the results, but let me just go to the code and explain you briefly what we have done. So the data that you can see over here on the screen is the brief data that we received from the company. And we've performed our analysis as follows. So we have charted down the data on the coding screen to make our process easier and faster. And the code here just explains the proc module that has been used to calculate the forecast for the water necessities. And we have done it separately for the cooling and for the main. And we have used the sum of them for our further analysis for the optimization. And if you look at the output over here, this is for the main requirement, and you can see the values. So this is basically what we have charted out in our presentation as well. So this is for the main, and as you can see, this is the forecast that we've come up with for cooling. Now moving on, if you can see here, for optimization, okay, let's be honest. So since we were on a time constraint, we've tried our best and to come up with our solution for optimization, but we were not able to deliver on it. But we have shown our effort. So since we were, this is the code that we came up with to show our working towards the solution. And as you can see here, like I will briefly explain to you what we tried doing in the code and what track we were looking forward to so that we would reach at the result. So let's go back to the code. Now, as you can see over here, from our forecasted values, we were able to compute the total requirement of water that the company would need for the coming month. That's the next 4 weeks. And we were also given the data about the current storage capacity, that is 62,500 gallons. And moving on, you can see the code over here. We've been able to define variables for like the storage, the cost, and the percentage of water that the storage tank will be providing. And the constraints are defined over here as well. So the storage tank will provide a minimum of 25% and a maximum of 1, which means like the complete water. on the basis of these constraints, we were able to define the other cost function. So we had come up with an objective function for calculating the cost, which you can see over here. And this is what we've tried to work with. However, we were unsuccessful in reaching our result, and we're going to admit this right away. But this has been our effort till now. And finally, just to conclude, you can see the results that we've come up with. So basically, just reiterating, our forecasting result numbers were generally in line with the historical data, meaning that there was no anomaly in the pattern that we observed. And the optimization was, we were challenged with some semantic errors, which we had to work around. But that is something which is still in progress. So we have put this in our future scope. So we will work on it, and we'll try to come up with a solution. But this is it for our presentation, and this is it. Thank you.